Gentlemen, stay with me, okay? That's a floor and that's a box. I am applying a force P here. There's a normal force because the weight I'll say is 100 Newton, okay? And my reaction force is also 100 Newton. Okay. Now, I apply a force of 1 Newton. What will be my F?
1 Newton.
1 Newton, okay.
1 Newton.
I am applying a force of 50 Newton and the object is not moving. What is the value of F?
50 Newton.
50 Newton, okay, that's fine. Object is not moving and F is 50. I am applying a force of 70 Newton. Object is not moving. What is the value of F?
70 Newton.
70 Newton.
70. So what is happening while I'm doing this? My R value started moving. It was first here. When I increase the force, it moved to this point. When I increase the force further, it moved to this point. So my R shifts slowly in this direction. Okay, remember when I asked you to take moment at point A? Do you remember that?
Yes, sir. Yes, sir.
Okay, so my R is shifting. Now I am applying a force of 80 in Newton, and my R value is here now, and the object moves. Okay, so will it dip or will it slide? What do you think? My R is here. That's my R value. And it moved. What do you think? What happened? Did it dip or did it slide? Guess.
Sir, it will slide.
Yes, it will slide because the R value is within the boundary, okay, within the footprint of the object. So it slides, so it means my friction force, my current friction force is less than this is the maximum friction force we can achieve with μs. Am I right?
Yes, sir.
Okay, so hold on. I'm got confused here. Just a second. That's my μs and μs. So I have reached the maximum coefficient of friction. Yes.
सर अगर बॉडी मूव कर रही है तो ये अटेन होगी.
I reached it. Yes. So it means my F value, friction force, will be at the moment of slip. My friction F, this F, which is same as this one, will be equal to mu Sn. Agreed?
Yes, sir.
Yes, sir.
At the moment of slip, if it slides, it means my F value has reached this value. Is that right?
Yes, sir.
Okay, so if I have reached this value, maximum value, it means my R is within the boundary of the body footprint. Clear?
Yes, sir.
Yes, sir.
Now let me take another scenario. Okay, now I start again. Now it's a different floor, okay? It was wood, now assume it's concrete. So I'm taking a force of 10 Newton, my F is 10 Newton, okay? My R moved from this point, I'll let me show a dotted line, and it's moved to this point. I increase it to 40, object is not moving, my R moved to this point. Object is not moving. So my F is also 40. I increase this to 80 Newton. My R moved to this point at the edge. Okay, it has reached the edge and the object did not slide. So it means my F is also 80. I increase it by 0.1 Newton. My R cannot move any further, and the object is not moving. Object did not slide. Why the object did not slide? Because the F maximum mu Sn tells me that the maximum friction force you can achieve is 90 before it slides. Okay, this is the maximum friction force based on my mu, which tells me the object will slide if the friction force, if the applied force is above or equal to 90 Newton. But when I moved to 80 Newton, my R shifted to the edge of it. Even if I increase by 0.91%, the object cannot slide, because for the sliding I need to overcome the friction by to increase the applied force to 90, so that my friction force exceeds 90, then it will move. So what will happen, because it cannot slide, it will tip over. Is that clear?
Yes, sir.
So what's the condition of tipping over? Tipping over tells me that my friction force, this F, I'm talking about this F, okay? This F was less than mu Sn. Clear? Do you agree?
Yes, sir.
Yes,
Yes,
sir.
sir.
And the other condition is my R, the position of R reached half width of the object. Now this is width, okay? So when tipping occurs, it means my friction force was less than the maximum value, and the R reached the end of the reached the edge of the object. You agree with me on this one?
Yes, sir.
Sir,
Do you
can
agree on this one? Hmm?
Sir, can you repeat it again?
Okay, let me do it again, so that, because this is very important, because instead of going through the slides, let me make you understand here. Okay, let me start again. Okay, I'll use a bigger box there. I've got a box. On the floor, and it weighs 100 Newton. So the R is 100. Okay, that's the center point. I'm applying P force. and this would be my friction force at the contact. Do you agree? Normal force 100 Newton, reaction force 100 Newton. Agree?
Yes,
Yes.
sir.
Okay. Now, you do know that if I increase the P value, my R starts shifting. Remember? Do you agree with this?
Yes, sir.
Do you all agree with me? When I increase the value of P, my R shifts.
Yes, sir.
Yes, sir.
Agree? Because remember we did that moment example? Okay. Now, I apply P equal to 10 Newton. My F, this is my F, okay? This one is F, so I'm writing it here. My F is, oh, hold on. Before I apply anything, I know that this is a wood concrete interaction. So let us say my mu S is, let me take a realistic value. Let us find it here. Come on, give me that. Come on. Okay, is there any wood concrete here? Do we have wood concrete? You got wood metal. I'll use 0.2. Okay, so let's do 0.2. Okay, 0.2. Come on, wait.
Sir, concrete would be the 0.62.
Was it?
Yes, sir, I guess.
Yes, concrete point 0.6. I'll use 0.6. Yes, that's fine. 0.6. Let's use 0.6. So it's 0.6. Okay. So what's my maximum friction force at the moment of movement? At the moment it moves, what will be my friction force? Can anyone calculate this for me? Because N is already 100 Newton.
60.
60.
60 Newton, sir.
60 Newton. So you're telling me that the object will move if the P force is equal to 60 Newton. Do you agree?
Yes, sir.
Yes, sir.
The object will be at the point of movement when P is equal to 60 Newton, because that is the maximum friction that can be generated here. Any force above this, it will let go and the object will start moving. Agree with me?
Yes, sir.
Yes.
Yes, sir.
Agreed? Okay, so remember the maximum limiting force, friction force is 60 Newton. So let me go back to this. So I'm applying force of 10 Newton. This is the maximum, okay? Maximum, I'll write maximum so that no one gets confused. So I apply P 10 Newton, my F, this I'm talking about this F, okay? My F will be 10 Newton, am I right?
Yes.
Yes, sir.
Okay?
Yes.
So my F will be 10 Newton. So, and my R will move somewhere here. I increase it to 20 Newton, my F moves to 20 Newton, my R shifts somewhere here. When I move to 60 Newton, okay, is the moment of movement. My F would be 60 Newton, my R is somewhere here, and it will just slide. So at the moment of sliding, one thing is clear, that the value of my P or my friction would be equal to equal to mu Sn. You agree with this? At the moment of movement, my P, which is equal to F, will be equal to mu Sn. Do you agree?
Yes.
Yes, sir.
Yes, sir.
That's one condition, okay? And the second condition is my R will be less than, so my R will be within half width of the object. This is W. So this is my half width. So my R will be within the half width. You agree?
Yes, sir.
Okay.
Yes, sir.
So remember, if the object slides, it means that the friction force you generated reached the maximum value, and the value of your R, the position of the value of R remains within half width of the object footprint. Is that clear?
Yes, sir. Yes, sir.
Shall I move on?
Yep.
Okay. Okay.
And sir,
Recording is, yes, sir, sorry.
and when it will tuple over?
So I'm coming to that. Okay. So now let me get rid of this and this, and let me get rid of this. So this was the condition for sliding. So now let us go back to our example here. Okay, now, okay. Now I've got, let me, how can I increase, let me think, so that it makes more realistic value. Yes, yes, it will make more realistic, okay. Okay, I've moved my p-value from here to here. You will understand why. Okay, so P equal to 10 Newton, F is 10. There's no movement. Okay, my R moved here. I increase it to 30 Newton. My F is 30 Newton, object did not move, my R moved here. I increase it to 50 Newton. My friction force is 50 Newton. I am at this edge now. My R moved there.
Yep.
I now increase it to 55 Newton. My F will be 55 Newton, and the R reaches the edge. This is the impending moment, which means it is about to tip over. Okay?
Yep.
So two observations. One is that my F never ever reached mu Sn value. Agree? Because mu Sn is 60.
Yep.
So my F never reached mu Sn because it didn't slide. So therefore, it never reached mu Sn value. And the other observation is that the R reached, the position of R reached half width. Okay?
Yes, sir.
So, two conditions. For tipping, the object will tip if the friction force doesn't reach the maximum value and R reaches the edge of the body footprint. The sliding happens when F reaches the maximum value, but R does not reach the edge of the object footprint. Is that clear to everyone now?
Yes, sir.